All right, there are many types of special sequences in series. The first one we're going to talk about is one we call arithmetic. Okay, this is an adjective describing sequences. That's why I am using the pronunciation arithmetic rather than arithmetic, which is a math, meaning for math and doing computations. But we call this arithmetic. So an arithmetic sequence is, and there's, excuse me, a few different ways I could explain this, but probably the best way would be to call it a linear pattern. You've been doing lines forever. Arithmetic sequence is nothing more complicated than a linear pattern, and where each term is found by adding or subtracting a common number. So this idea of linear, it's going to help you with some of this that's about to come up. So this says state the common difference for each arithmetic sequence. Basically find the pattern. So what's the pattern in A? How do you get from number to number to number? Plus 4. Okay, make sure that that's the pattern each time. If it goes plus 4, then plus 5, that's something else. And so we call this thing the common difference. We call that D for common difference. And that's 4. If you add a number, the common difference is positive. If you were to subtract a number, the common difference would be negative. So what's the pattern in B? Be careful about that. It is negative. How much are you subtracting each time? 5. And so if you're ever having a hard time trying to just figure it out, just subtract. 2 minus 7, that'll give you negative 5. Okay, and as long as you're doing that each time, that's the common difference. All right, so to find a formula for a general term, this is where we come up with some kind of pattern with an n in it, okay? And so it's saying, what's something so that when I plug in a 1, I'll get 1. And if I plug in a 2, I should get 3. And if I plug in a 3, I should get 5, and so on. Now you could sit here and think about this for a while and probably come up with it. These are not such difficult to kind of guess and check your way through, but we do have a formula, all right? And here's the formula. It's the first term, a sub 1, plus the common difference times n minus 1. And sometimes you see this d on the other side, but it doesn't matter. You're just multiplying d times n minus 1. Okay? So, if we think about it, a sub 1 for this problem, okay, if I come over here and try to do this, a sub 1, that would be 1. What's the common difference in this example? You're adding 2, so we would go 2 parenthesis n minus 1. And I want to simplify this, okay? So we're going to distribute the 2, and then I'm going to go 2n, and then 1 minus 2 is negative 1. Okay, so this right here is really our final answer because it's simplified. And you're going to have a calculator. You need to be able to do this. All right, now, does this look like a line to you? Okay, let me put a line right here. mx plus b. I'm running out of space here, but I'm gonna if you can follow where I'm going with this right here, it's gonna help you. I'm gonna write it down here just so I can have more space, but then I'm gonna erase it. Okay, look at this mx plus b. Do you see how the n and the x are in the same spot? What has replaced slope? What number is where the slope normally is? It's a 2, right? That's the common difference. All right. B is the y-intercept. This is like actually the 0th term. So think about if we went backwards. We know we add 2 to move the pattern forwards. What if we went backwards? We would subtract 2, right? So what term would be back here? Negative 1. That's not a coincidence. That's a negative 1 right there. This is a formula that we're going to give you. But I think some of you are good with a shortened down version of the formula. And if you can remember this, you can use it. It won't be given to you though. So dn plus a sub 0. Okay, it's a different formula, and I'll put it in parentheses. It won't be given to you on a quiz or a test. The other one will. So I want to kind of explain this a little bit more. I'm probably not going to use that formula a whole bunch. I'll probably just use the one that we're going to give, but some of you are really good at memorizing, and I think you might want to do that. Okay, so if you look at this next one, it says find the formula for the nth term. Okay, so what we need is I'm using this formula right here. We need the first term. Okay, we need the common difference times parenthesis n minus 1. And all I got to do from here is simplify it. So 3 plus 2n minus 2, just distribute the 2. So 2n, and then 3 minus 2 would be 1. Okay, that right there is the formula for this particular pattern. Okay, another totally different way you could come up with this plus 1 is to, instead of adding 2, subtract 2 from the first term. So that's there. All right. Ooh, what's weird about b? It doesn't even give us the first term. Okay, but this is where, if you remember that this is linear, okay, what is the common difference like? It's like slope. Do you remember slope formula? Please say yes, even if you're lying. Okay, slope formula is y minus y over x minus x. That's actually how you can find the common difference here. Okay, think about this. If the 8th term is 26 and the 12th term is 38, you're going to add some number how many times to get from here to here? Uh-oh, my pen stopped working. All right, how many times do we have to add a number to get from the 8th term to the 12th term? 4 times. Okay, so I'm going to show you a couple of different ways to find D here. You could say that, okay, 26, if you add D 4 times, you should get to 38. Okay, I want you to find D. You do this on your own. Solve that equation. Yeah, so if you remember that this is like slope, you can actually get this 3 number a little bit more directly. You can just subtract the 2, basically terms, y values, 38 minus 26, divided by the x numbers or the n numbers. Okay, either way you're going to get 3. These are 2 kind of different ways. They're related, but that's how we get 3. That's what you got to find first. Okay, what do we need to find next in order to write the formula for the nth term? We need to find A1. So again, you kind of have some options. If you know the 8th term is 26, and you know the pattern is to add 3, we could just go backwards and subtract 3 however many times we need to do that. Okay, if that makes sense to you, do that. If that doesn't make sense to you, here's one thing we could do. Remember the formula. Whoops, sorry. That's not what I meant to do. And I'm kind of doing overkill on this particular one because it really applies to a whole bunch of problems. And when the numbers are all whole numbers and positive, it may not, there may be an easier way, but if the numbers got weird, you may need a different way of doing it. Okay, watch what I'm going to do on this next one. I'm going to plug that in right here. I'm going to plug 26 in right here. I don't know a sub 1. D, I just found out, is 3. And then n right here is 8, so I would write 8 minus 1. So you can solve this equation out to find a sub 1. Okay? Did anybody subtract 3 several times? What did you guys get for your a sub 1? Everybody taking their 3-day weekend a little early? Got 5? That's correct. If you solve this equation, you're also going to get 5 because you're going to do 3 times 7, which is 21. 26 minus 21, that's 5. So here is just using the formula. I would write 5 plus d is 3, n minus 1. And this is my answer, although it's not totally simplified, so I would need to do that. I need to distribute the 3 and combine like terms. Okay, that was a lot of steps, lots of chances to make mistakes. So here's what I would suggest you do. Use either of the terms. I'll use this term. If a sub 12 should equal 38, then I should be able to plug in 12 right here, and I should get 38. So double check that. Let's make sure we got a good formula. Is 3 times 12 plus 2 38? Yes, it is. So that's a way you can kind of check your work. We're going to skip C just for time, okay? I know y'all are heartbroken about that one. It's very similar to the one we just did. All right, turn the page. And now we have this phrase series. Do you remember the difference between a sequence, which is a pattern, and a series? What is it? What do you do in a series? Add it up. So an arithmetic series is the sum of an arithmetic sequence. An arithmetic sequence is probably the most basic sequence you can get, so we're going to come up with a formula here in a minute. But I just want y'all to kind of use logic for just a second. Can you add up all the odd numbers 1 to 99 without a calculator? If you're thinking, okay, 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16. If you're doing it that way, you're working too hard for your money here. Okay, look at this. What's 1 plus 99? What's 3 plus 97? 100. And so on. Okay, all the way down to right in the middle there, you would have plus 49 plus 51. These are the odd numbers that would be in the middle, right? And that also equals 100. So the question is, how many pairs of numbers do you have? Because if we figure that out, we can just go times 100. So what do you guys think?
50.
You think 50 or 49?
49. Wait, can you count 50 twice? Is the number 50 twice?
So 50 itself isn't even in the pattern. So my question really here is 1, 3, 5, and so on to 49. How many odd numbers is that? It's actually not 50 or 49.
24.
It's 25 or maybe 24. It ends up being 25, but that's how you do this. And then you multiply by 100. There are 25 pairs. Okay, now here's the deal. You don't have to do this stuff without a calculator. I will tell you there was a mathematician named Gauss who the teacher put up on a board, this is like a few hundred years ago, and said, I want y'all to add up the numbers 1 to 100. And can you put that away for now? I want you to add up the numbers 1 to 100, and the teacher just did it to kind of make this, like, keep the students busy. And he was like 7 years old, and he did it in like 30 seconds. And that's how they figured out he was pretty smart and probably needed some better math teachers, teach him more stuff. So that's kind of how this pattern works, okay? It has to do with there being pairs. The first and the last number, the middle numbers, all of those should be the same thing. You just have to figure out how many pairs there are. All right, so here's the formula. If you're adding up in numbers, S here stands for sum, you would say how many numbers that is, okay, divided by 2. It's kind of like what we did with 50 divided by 2. And then you would do the first plus the last. You don't have to memorize this. F and L stand for first and last. Write that down on your notes if you think you're going to forget it. Okay, this will be given to you. Another way of thinking about this is, what happens when you add up two numbers and divide by 2? What are you finding? The average. So if you can average the first and the last term and then times that by the number of terms, it's basically the same formula. So if we were making you memorize, that's kind of how we would do it. But we're not, so moving on. Okay, so you need however many terms there are. You need the first term and you need the last term. So here, in trying to find S sub 30, okay, there are 30 terms. So that's why I'm plugging in right there at 30 over 2. We know the first term is 38. Now, I'm going to leave a blank here because I don't know what the last term is. Okay, once I figure that out, I can finish the problem. So I got to go over here and do a little bit of work to figure that out. Okay, well, can you come up with, use what we did on the front. Okay, so just as a reminder, let me write this right here so you don't have to keep flipping back and forth. Okay, so the first term was 38. What's D here? What are you adding or subtracting? 38 to 33 minus 5.
So the lowest number can be 3 before you get a negative, right?
So if I want to find A sub 30, yeah, if I want to find A sub 30, I'm just going to plug 30 in right here. We could have simplified it and then plugged in 30, or we can just plug in 30 right here. So go ahead and figure out what A sub 30 is. And that's the number that's going to go over here. And use your calculator here. You don't have to do this in your head. You could, technically, but, you know, it's like, why? Yeah, just in that green tray. You should be getting negative 107. Okay, that's the number that's going to go here. That's the last term. So then type all this in your calculator. And then once you get a number here, I want you to check it with your neighbor. We're almost done. So the whole reason we have this formula is because without it, we would have to actually write out all 30 terms and then physically type all of them in and add them up. This is what the formula saves us from. Okay, what are we getting here? Negative 1035? Yep. It's okay if the answer's negative. That'll happen sometimes. Okay, let's look at B. Okay, we're going to add up the first 10 terms. That's what that S sub 10 means. So we take 10, we divide by 2, and then now we need to add the first term plus the last term. And again, they didn't give us the last term, so we got to go over here and find it. So we do that by using the formula from the front page. It says take A sub 1, which is 8, add that to D. So you got to find D. That's always going to be important here. 8 to 20, that's adding 12. And you don't have to simplify this because it's not your final answer. You do, though, have to plug in 10 so that you can find the 10th term, which is the last term in this series. You should have gotten 116 for that 10th term, and so now you're just plugging this back to this formula. Any questions so far? Okay, we got two more. They look different. Do y'all remember what that Greek letter is called? Sigma. S-I-G-M-A. It's a Greek letter. It's a capital Greek letter, sigma. It means summation. Remember, the number at the bottom tells you to start with that term. So in this case, that's a 1, and then stop with the 24th term. We're still going to do the same S, okay? And if you're not sure what number to write here, don't write any number, because on some of the ones we're about to go through, it may be not clear what we need to write, okay? How many terms are there if you start with 1 and end with 24? How many numbers is that? Think about this. If we numbered off 1 through 24, how many people would we have? 24. So why would someone get 23? Because they subtract those two numbers. That's going to be misleading. If you just subtract these two numbers, you need to add 1. And that's going to be important here. So it is 24. We divide that by 2. That's part of the formula. And then you got to plug 1 in to find the first term. Go off here to the side if you need to. So a sub 1 would be 2 times 1 plus 1. That's going to give you a 3. And then the last term would be, we'd look at that top number and we'd find a sub 24. That's going to be 2 times 24 plus 1. So it's still number of terms divided by 2 times, in parentheses, the first plus the last term. The rest is calculator work. Okay, so for part D, how many numbers are if you start at 5 and end at 13, how many numbers is that? I mean, this is where most people, this is like, people are like, I got this, I got this. This is where they make a mistake. Because they go, 13 minus 5 is 8. But that's not right. Because if you count on your hand, if you're like 5, 6, 7, 8, 9, 10, 11, 12, 13, how many numbers is that? 9. For those of you watching the video, I'm now counting on my fingers. This is what we're coming back to, is finger counting. So if you subtract, you got to add 1, okay? So this is why I wasn't writing a number here, because it's kind of misleading. Do you put the number of terms here? That is what you should do. Or should you put the top number there? So if you're not sure, just leave that off and leave it as an S and everything's fine. Okay, can I still use 3 plus 49? Listen to the tone of my voice. Can I still use 3 plus 49? No. Because this series starts with 5. So I need to come over here and find a sub 5. 2 times 5 plus 1. That's 11. That's the first number of this series. The last number of this series, whoops, not a 2, would be a sub 13. So you always got to plug these numbers in to find what you got, okay? So that would be 2 times 13 plus 1, which would be 27.
Where'd you get the 9?
So that's the 9 is the number of terms you have if you start with the 5th term and end with the 13th term. A shortcut to getting that is to subtract and add 1. You're going to lose